Today's math lesson, we're working with prime and composite numbers. This might be reviewed to some of you, others this might be new, so let's take a look. There's two different types of numbers. There's a prime number and there's a composite number. Here, these are all prime numbers. Take a look at what all these numbers have in common. Go ahead and press pause if you want to look at it for a little longer. Let's look at these numbers here. 2, what are all the numbers? How do you get the 2? 1 times 2 equals 2. Are there any other numbers that you can multiply to get 2? The definition, only the number 1 and itself can be multiplied into it. These are all prime. Number 3, 1 times 3 equals 3. Can anything else go into 3? No. Let's jump down to 11. 1 times 11 equals 11. 2 times the number, does that equal 11? 2 times 6 equals 12. So no. 13, 1 times 13, 17, 1 times 17, 19, 1 times 19. These are just the lowest prime numbers. There's higher prime numbers. A prime number is not just an odd number, okay? Because you'll be noticing here that 9 is not a prime number. And I'll be showing you that right here. 9, as you can see to the far right there, is called the composite number. Composite numbers are different than prime numbers because more numbers than 1 in itself can be multiplied into it. Please keep this in mind, prime and composite. Kids always kind of get these mixed up each year. Just look closely at it. So a composite number, the number 4 is composite because 1 times 4 equals 4. That means it would be prime, but it's composite because 2 times 2 also equals 4. There's this other option that helps make this composite. Take a look here, 1 times 6, of course. If it was just this, it would be prime. But because 2 times 3 equals 6, it makes it composite. 2 times 4 makes this a composite number. 3 times 3 makes this composite. So there's more than just the number 1 in itself. Remember, just quick little review. A prime number, 1 and the number itself are the only numbers that go into it. Composite number, other numbers can multiply to get into it. Let's do some examples of prime factorization now. This is what prime factorization is. It's called prime factorization trees. So take a look. We start with the number 42. And then we're going to make some roots. I like doing this. It kind of looks like a tree roots. 7 times 6 equals 42. Once you get a prime number, 7's a prime number because only 1 times 7 equals 7. You circle it. Do you see how 6 isn't circled? Now I have to make more branches again. 2 times 3 equals 6. 2 is a prime number, 3 is a prime number. Once I can't make any more roots off of these, I'm done. Then I just make a little number sent to the side. 2 times 3 times 7 is my prime factorization of 42. Let's take a look at another example here. 110. 11 times 10 equals 110. 11 is prime, so I'm going to circle that so it's over. To break 10 apart, 2 times 5 is 10. Circle these because they're both prime. Here is my prime factorization. Let's do the number 48. Well, what two numbers multiplied by each other equals 48? We can do the easy one. We've got 6 and 8. Now I have to break 6 apart because it's not prime, it's composite. I'm not going to put 1 and 6 down. The reason why is because then I'm back at the start. So make sure you're not doing you're doing anything else besides 1 and the number. I've got 2 and 3. Well, 2 is prime, 3 is prime. With 8, let's go 4 and 2. 2 is prime. Can we break 4 apart? We can. 2 and 2. So our answer should read 2 times 2 times 2 times 2 times 3. 2 times 2 times 2 times 2 times 3. Let's do another one. 120. Well, this one right here, we're going to start off with 12 and 10. Both of those are composite numbers, so let's break them down. 12, let's go 6 and 2. 10, let's go 2 and 5. Now we're going to take a look. Do we have any prime numbers here? Is 6 prime? I'm going to think of any other numbers besides 1 and 6. I've got 2 times 3, so that means 6 is not prime. 6 is composite. 2 is prime. 2 is prime. 5 is prime. So let's break apart the 6 to 2 and 3. Both prime numbers. So my answer should read 2 times 2 times 2 times 3 times 5. Perfect. 36. Let's break this apart. Let's go 6 times 6. both composite numbers. 2 times 3, 2 times 3, prime, 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 prime. What do I have for an answer? 2 times 2 times 3 times 3. I could write 2 times 3, 2 times 3. It's fine. Kind of makes sense when you put it from smallest to largest. 525. Can we break that down? Absolutely. Yesterday's lesson was divisibility. Let's see if we can break this down. I know 5 can go into this large number because it ends with a 5. So out here in the sky, I'm going to go 525 divided by 5. 5 goes into 5 once. 5 times 1 is 5. Subtract, bring down the 2. 5 goes into 2 0 times. Bring down the 5. 5 times 5 equals 25. 0. 105. So I'm going to break this apart to 105 and 5. 5 is prime. Now I have to break down 105. Well, 20 times 5 is 100. So 21 times 5 would be 105. Well, 5 is prime. Is 21 a prime number? Kids get confused because it's an odd number. But can we think of anything else besides 1 times 21 that equals 21? This is why you need to know your facts in 5th grade. We actually can. 3 times 7. 7's prime, 3's prime. 3 times 5 times 5 times 7. Hopefully this helps a little bit. Let's take a look at what your assignment looks like here. Today you get the opportunity, or tomorrow or today, you'll be getting the opportunity to work on these problems. So let's take a look at the number 2, for example. List all the factors of 2. You got 1 and you've got 2. Is it prime or composite? It is prime, because there's only 1 and 2. So these problems right here, you're actually going to be making factor rainbows for, so you don't forget any, okay? But this will also teach you what is prime and composite as well. So number 4, make a factor rainbow, 1 and 4, 2 and 2. So I'm listing the factors. I got 1, comma, 2. You don't have to write 2 twice. 4, prime or composite? This is composite because it has more than 1 and 4. Hopefully that makes sense. I'll jump down to 16, help you out with 16. Got 1 and 16. Got 2 and 8, 4 and 4. So I'm gonna have 1, comma 2, comma 4, comma 8, comma 16. Easy, this is a composite number because it's more than just 1 and 16. Please don't forget big numbers with 34, big numbers with 36, big numbers with 38, 39. There's big numbers that go into those. And what I mean by that is you might be multiplying 2 times a big number to get to 34. Just keep that in mind, kids, when you're going through. Right here, you'll be listing more factors. Go ahead and do a rainbow here. I'll help you out as well. Hopefully this made sense. Today you're not going to be doing a whole lot of prime factorization, but it's going to help show you what a prime and composite number is. We'll be doing some more practice with prime factorization in the future.